Hi everybody, here we're going to go over the instructions for the magnetic field versus electric current lab. So let's go ahead and take a look at the outline for the lab. So besides the error section, there's going to be some settings that you'll have to enter here once you begin the experiment. So make sure you read the instructions to see what settings you're going to enter. And you have your formula sheets. This time the formulas are numbered. And also there's gonna be some linearization, so you have a guide here to linearize your graphs. And so this experiment is gonna have two parts. So part one, you're gonna measure magnetic field versus distance. So you're gonna enter the magnetic field versus distance data here, and then you'll make a plot of the magnetic field versus distance. And you're also going to linearize the data. You're going to enter the linearized data here, and then you're going to get a linearized graph. So that's going to be part one, magnetic field versus distance r. And in part two, that's going to be magnetic field versus electric current. So part two, you'll be adjusting magnetic field versus distance, and then you'll be plotting that data. Okay, so let's go ahead and take a look at the simulation. So once you click the simulation, there's a couple of options. First, you're going to click on grid. And next, you're going to click on here for directional electric current. You're going to set that to conventional current. And then after that, so if you click here, you can move this sensor up and down. So up and down, we're going to define that to be the radial direction R. And then side to side, we're going to define that to be the axial direction Z. So you read the instructions, and you're going to have to identify what the coordinates are going to be. So the horizontal coordinate is going to be the Z coordinate, and then the vertical coordinate is going to be the R coordinate. So you just have to read the instructions to decide where you're going to place the crosshairs when you do the experiment. So for for the settings, here you're just going to make sure that you enter on, that you set the grid to on, and you also have set the conventional the current to conventional current once you've done that here. So the grid is on, and the current has been set to conventional current. Okay, so that's going to be it for the settings. So now let's go ahead and take a look at the data part. So for the data part, so you're gonna keep the Z coordinate constant for the experiment. So make sure you read the instructions, because there's gonna be a specific value that you're gonna be asked to set the Z coordinate to. So you'll adjust the Z coordinate to a particular value, and then once you've adjusted that Z coordinate, then you're gonna record that Z coordinate value over here. So where it says Z. And then next, you're gonna set. So now you can also, let's see, so you can also click on current here, and you can adjust the value for the current. So here the currents are randomly generated. So what you're going to do is you're going to choose three different currents. So low current, and we're going to find the low current to be anything near 1 amp, and then a middle current will be any current near 5 amps. And then a high current, which is going to be anything near 9 amps. So you're going to get slightly different values, but each student is, for part one, is going to get three different currents. Here, this is going to be my high current, and then here would be my middle current, and then this is going to be my low current here. So for part one, you're going to set the value to the lowest non-zero current, and you're going to record that value here. So this is going to be my lowest non-zero current, so I'll record that over here. And then what you're going to do is you're going to change the radial distance, and you're going to record the corresponding magnetic field. So what you'll do once you set the current to the lowest value, you're going to keep the horizontal distance the same, and also, so here you see the distances are already given to you, so this should be set to initially 1 centimeter. So you'll move the magnetic field to 1 centimeter, and at that location you're going to record the magnetic field. So you just click on field strength, and you're going to record this magnetic field over here. And then next, you're going to change the radial distance to this new value. It's going to be 1.5 centimeters. So you just move it up one. And then you record the magnetic field at that location. And then you just complete the table for trial 1 here. So you're going to get a plot of magnetic field. Well, you're going to keep the current constant. And then you're going to get a plot of magnetic field versus distance. And you'll complete this table here. Trial 2 over here. So for trial 2, it's going to be similar. The only difference is that you're going to set current 2 to the middle current. So you'll increase the current to somewhere near 5 amps, depending on what your random number you're given here. And you record that current. That's going to be my I2. And then you're going to record that over here. And then you repeat the same experiment. So for each corresponding distance, radial distance, you're going to record the magnetic field B2. So you'll just move the radial distance to a new value, and then record that magnetic field, and then move the radial distance to another value, and record the corresponding magnetic field. And that's going to be similar to trial 1. You'll fill in the data, the table for trial 2, and for trial 3. Here for I3, you'll just repeat the experiment for here, the highest current, the one that's closest to 9 amps or 10 amps. And after that, this will complete the data taking section for, let's see here, for section 6. So once you've completed the data taking section for section 6, then what you're going to do is you're going to create a graph here. And the graph is going to be, you're going to plot magnetic field B versus radial distance R. And so here, I want you to only have one graph. And on that one graph, you should have 3 trend lines. You should have 3 graphs. One graph is going to be for trial 1. The other graph is going to be for trial 2. And the other graph is going to be for trial 3. So you should have 3 different functions or graphs, or 3 different, let's say 3 different trend lines on one graph for magnetic field for trial 1, trial 2, and trial 3. And you should also have a legend to help you identify which graph is going to correspond to which color graph is going to correspond to which trial. So once you've gotten that graph, you're going to decide whether, if you go up to the error analysis, for the linearization section, based on the shape of the graph, you'll decide whether the graph is linear, is it quadratic, is it exponential, or is it a power graph. So based on the shape of your graph, you're going to decide, what the initial non-linearized graph looks like. And so then you're going to go to the next section. Where you're going to linearize the data. So based on your choice, or based on your observation for the shape of the graph, you're going to decide whether, what are you going to do to the horizontal axis to get a linear graph? And also what you're going to do, how you're going to manipulate the vertical axis to get a linear graph. So based on your choice, then you do the corresponding calculation. So if this is, if I chose R2 here, then you'll just go up here and just take that number and square it. And then you're going to enter that over here. And here, if I'm choosing natural log of B, so that means that you'll go up here. This corresponding value for B, you'll take the natural log, and then you're going to enter that over here. So pretty much the same data that you have for trial 1. To linearize it, you'll do the corresponding operations and then fill in this table here. And then similarly for trial 2 and then for trial 3, you're going to make your choice of what should be, what should the t-axis be, and what should the u-axis, or the horizontal t-axis and the vertical u-axis be, to linearize the graph. And then you'll complete this table following the corresponding operations, and do the same thing for trial 3. And once you've completed the linearization data, then you're going to go to section 9, and you'll plot again on one graph the linearized data. So in this case here, you should have three straight lines, And you should each straight line should have a corresponding legend, so you can tell by color which graph corresponds to which trial. So you're going to have 3 different trend lines here. And so then what you're going to do is add an equation for the trend line, and then so be able to record the slope of those 3 trend lines, slopes of those 3 trend lines. And once you've gotten the linearized data and the slopes, then over here, this is where you're going to record the slope for trial 1, the slope for trial 2, and the slope for trial 3. And so what those slopes are going to correspond to is going to be the relationship between the magnetic field and the distance. So that's what that value for n is going to give you here. And also here you're going to record the y-intercept. So this should be a straight line that you're going to plot here. So from that straight line, you're also going to record the y-intercept from the graph. And you're going to enter the y-intercept here for each of the 3 trials. And based on that, you're going to calculate the permeability of free space based on your data. And the way that you're going to calculate the permeability is going to be, so this is going to be experimental permeability. So you're going to go up to the reference formulas. And so if you look at it here, equation number 2, it has an equation in terms of the permeability and the y-intercept. So you'll use this equation here, and you'll have to solve this equation in order for the experimental permeability, and then you're going to enter that value over here. So then this is going to correspond to your experimental permeability for free space. And then next, here you're going to look up, so here for the n theoretical, that's going to be the theoretical dependence of magnetic field versus distance. So then here you're going to go up back to the reference formulas, and you're going to analyze equation 1 and see how, how magnetic field depends on the variable r. So based on your choice for, what power r should be, then you're going to enter that corresponding dependence over here. That's going to be the experimental, that's going to be the theoretical dependence of a magnetic field versus distance. And next, after you've gotten the theoretical dependence of magnetic field versus distance, then here what you're going to do is go back up to section 10, and you're going to get the average of your experimental dependences of magnetic field versus distance, and you'll put the average of those numbers over here. And then you're also going to calculate the error of this experimental dependence of magnetic field versus distance, and the formula is just going to be a standard deviation of the mean. So over here it's just going to be the standard deviation of the mean of the experimental power dependences. And also the percent error between the theoretical power dependence and your average experimental power dependence. You're going to put that over here. Also, you're going to look up the theoretical value for the permeability of free space, and you're going to enter that number here. Make sure you turn that into, write that in scientific notation, in terms of decimals. And after that, here, what you're going to calculate is your calculated permeability, experimental permeability of free space, these 3 numbers here. This is going to be the average of those 3 numbers. And you're also going to calculate the error in your experimental permeability, also using the standard deviation of the mean of those 3 permeabilities. So that's going to be formula number 5 here. So it'll just be the standard deviation of your standard deviation of the mean of your 3 permeabilities. And that's what you're going to calculate there. And that should complete part 1 of the experiment. So now let's go ahead and take a look at part 2. So part 2, it's a similar setup. So part 2, you're going to again set your z value to a particular number, and you're going to record the z value here. And then for part 2, you're going to keep the distance fixed. So make sure you read instructions, because you're going to set the distance to a specific, for part 2, you're going to keep the radial distance fixed. So make sure you read the instructions to see what your initial radial distance should be set to. So your value for R1, and your read instructions to see what that number should be. You're going to enter that there, and then you're going to set that value, the radial distance, initial R1 here. And then what you're going to do is now you're going to change the current and record the corresponding magnetic field. So you're going to start with the lowest current. So for the lowest current, you're going to record this current here and this magnetic field here. And that's going to be what's going to go over here. And then next, you're just going to increase the current by one step and then record the corresponding current and magnetic field over here. And then just repeat, you're just going to increase by one step and then record the current and magnetic field, and you're going to complete trial 1. Trial 2, you're just going to change the radial distance. So you'll reset, you'll drop the current to the minimum value, and you're going to change the radial distance to another defined value, another value that's defined in the instructions. So once you set that corresponding radial distance, then you're going to repeat the experiment. You're going to increase the current, record the magnetic field, increase the current, record the magnetic field, and you'll complete this table here. And the last one is just going to be a final value for the radial distance. So you'll move it to some maximum value for the experiment, and then you'll do the same thing. You'll start with the minimum current, increase the value, record the magnetic field, increase the current, and record the magnetic field, and then you're going to finish trial 3. So once you've completed trial 3, here you're going to make a plot of magnetic field versus current. And here again it should be one graph with 3 plots, and the 3 plots should have a corresponding, each should have a corresponding legend, so that by color you can tell plot, one color corresponds to trial 1, and one color corresponds to trial 2, and one color corresponds to trial 3. And so here, if you go back to the reference formula, number 1, this should be magnetic field versus current. It should be a linear relationship here. So here, it should automatically come out to be a straight line. And so you're going to record the slope of that straight line here. So you'll record the slope, enter into that here. So now you're going to get another. You're going to calculate the permeability of free space, but now using a different option. So this is going to be the permeability of free space, but now for part B. That's going to be what I call mu B experimental. So to get mu B experimental, you go up to the reference formulas. So that's going to be equation number 3 here. So you have the slope, you have mu B experimental, and divided by 2 pi r. So you have to solve that equation for the permeability of free space for part B experimental, which is going to correspond, well, that's going to be defined in terms of the slope. So you'll use this equation to solve for mu B experimental, and you're going to enter that over here. So that's going to be for trial 1, and then for trial 2, and then for trial 3. So you don't need to enter any units for the slope here. And then you'll complete the experiment similar to the first one. You're going to re-enter your theoretical value for the permeability of free space. And then this is going to be over here. This will be the average. So this permeability here is going to be the average of your permeability, the permeability of free space that you got for part B, just the average of those 3 numbers. And then again, the error for the permeability should be the standard deviation of the mean of the permeability that you got in terms of the slope. And then you'll complete the experiment by taking the percent error between the experimental permeability of free space and the theoretical permeability of free space. And that should complete the experiment for magnetic field versus current.